Math, Geometry, Unit 1, Lesson 5 is called Construction Techniques 3, Perpendicular Lines and Angle Bisectors. So our goals today are I can define an angle bisector. I can construct an angle bisector using a compass and a straight edge. And I can construct a perpendicular line through a given point on a given line using a compass and straight edge. All right, we'll start with this warm-up here. Points A and B are each at the centers of circles of radius AB. So A and B are at the centers of circles of radius AB. So they share a radius. So you can right away conclude that these are congruent circles. Circle A is congruent to circle B. Compare the distance EA to the distance of EB. Be prepared to explain your reasoning. So this is something that we learned in an earlier lesson. So segment EA is going to be congruent to segment EB. So if I were to connect them here, you see there that they share a radius AB, so the circles are congruent. Therefore, any radius on circle A or any radius on circle B are all congruent. So this is how we learned how to do the equilateral triangle right there construction. You basically just make two congruent circles and connect the intersection points with the radius that they share. Okay. Compare the distance FA to the distance FB. So that's kind of the same thing. I'll do it in a different color here. There's the shared one. FA is congruent to FB because they share a radius and all radii on both these circles are congruent. So right away we can say that segment FA is congruent to segment FB. Draw a line EF and write a conjecture about its relationship with segment AB. So draw a line EF. Now, if you have a straight edge, use your straight edge. I have a tool that works for me. So make sure it's a line. It said line EF, so make sure you have arrows. And this is what we learned the other day. We learned that this is a perpendicular bisector. So I mark it perpendicular with the right angle and I bisect it. So I will just say that line EF is a perpendicular bisector. Oh, you know what? I need to change the setting there. So perpendicular, I'm going to use the abbreviation bisector of, what are you bisecting? We're bisecting segment AB, okay? Line EF, segment AB, okay? And this is all review stuff. This is all review. If you didn't watch my earlier lessons, go back and watch 1.1 through 1.4. All right, so we're going to learn a new construction. Steps for constructing a perpendicular line through a given point on a given line. So here's my given line, line M, and here's my given point, P. So I want a perpendicular line through point P. Okay, now do not confuse this and say it's a perpendicular bisector. You cannot bisect a line that goes on forever. You got these arrows here. You cannot cut it in half. You cannot cut it into two congruent segments because it goes on forever. So we are not constructing a perpendicular bisector. We are just constructing a perpendicular line. Make sure you have your vocabulary right. If you get asked a question like that on a test or a quiz, okay? So construct a circle of any size centered at the given point. So let me get my protractor out. All right, so I put that right there, my point there, I open it up. It doesn't really matter. I'm going to keep it somewhat small because the bigger it gets, then it starts, becoming like off my paper and all that kind of stuff, okay? So there's my circle, any size, centered at a given point. Label the points that intersect the line as A and B. Okay, so here's A, there's B. Construct two circles that have a larger radius than the first circle you constructed. One centered at A, the other centered at B. Label the intersection points C and D. All right, so I have to open up my compass and make it bigger. I'm going to show you why. I'm going to erase this in a second. This is actually wrong. Don't leave it the same size because look, if I do this, do you see how they don't intersect at 2 points? They just intersect right there at P. That's not going to work, okay? So I'm going to open it up a little bit bigger. I can make it the same as AB, or it can just make it a little bit past the point that we originally started at. Then I draw a circle there. Then I move it to B, and I draw a circle there. And those points where the two bigger circles intersect, I'll do them in red. I'm going to label those C and D. And then you take your straight edge and line it up right there. Here, I'll use my straight edge this time instead of my line feature. And there it is. I put my arrows on. Okay, and you look there, it sure looks like it's perpendicular. So I put my 90 degrees there. Okay, so line CD right here is perpendicular to the initial line and through the initial point. Okay, so that's how you do it. Now, I will show you this too. You really don't need the full circles. If I go back and get rid of this. Whoops, what did I do? There we go. If I just do this, if I just mark kind of like up here, and then if I mark kind of down here, we just need where they intersect. You'll find your drawing is a lot cleaner. Whoops, that's not right. Right there. And right there, you'll find it makes it a lot easier because you don't have to have as much all over it. You're just looking for the intersection point. So it makes it a little bit neater, a little bit cleaner. The more and more you do this, the more and more you'll like doing it like that, where you don't actually draw the full circle. Okay. All right, same idea. There you go. Okay. The key is this first circle, though, because these points have to be equidistant. So then you're basically, once you get A and B, you're doing a perpendicular bisector of segment AB, but the whole thing is a line. Okay. All right, so one of our other goals was we can define an angle bisector. So an angle bisector is a line, ray, or segment that divides an angle into two congruent angles. So I got congruency marks here. Sometimes they just mark it with a little arc there, and they stagger them. Sometimes they put like a little tick mark on there too. So you can see this is one, so we know that these angles are congruent. So, over here we'd say angle W X Z is congruent to angle Z X Y. All right, and these angle measures are going to be congruent too. So if I took my protractor here, it's just for fun. Let's put that right there. Let's turn this. You can see that it's about 40 degrees. Yeah, it's about 40 degrees right there. It goes from 0 to 40. And then if I do the same thing right here, you can see it's also 40 degrees as well. So if you wanted to write with the proper notation, we could say the measure of angle WXZ is equal to the measure of angle ZXY, which equal 40, okay? So we usually say angles are congruent, but measures are equal, Okay, same idea over here. Angle AOC is congruent to angle COB. All right, and the angle bisector, I guess I should define the angle bisector. We could say that ray, I guess I should go back here, ray X Z is an angle bisector of angle, the big angle WXY. Okay, same idea on this one. We would say that ray OC, okay, starting point first, and then the point that the arrow goes through. I guess they should have put a point here for C. I'm going to put the C right there. Okay, move that. Ray OC is an angle bisector of angle AOB. Okay, so draw a ray that is a good estimate for an angle bisector and write a congruency statement for the two congruent angles. So this is just an estimate. This is not exact, obviously. I'm going to try to make two equal angles. Obviously, that's not equal, not equal, not equal. That looks pretty good. I'm going to go right there. Now, I need to put a point here. Call it, I don't know, D. So we would say angle MQD is congruent to angle DQP. And we'd say ray QP is an angle bisector of angle MQP. Okay, so looks like we're pretty good at defining an angle bisector. Let's see if we can construct one. So steps for constructing an angle bisector when given an angle. 1, construct a circle of any size centered at the vertex. Let's call the vertex B, okay, of the given angle. Mark the points that intersect the circles as A and B, okay? So I'm going to get my, you know what, hang on, let me get a different color here. Let's do it in blue. All right, so I'm going to put my center right there. I'm going to open it up. Doesn't have to be huge. Make a circle right there. Okay, that gets every point here equidistant from V. So now we're going to construct two circles, one centered at A. Oh, I need to mark these, label these AB. So this point here is A, and this point here is B. All right, step 2, construct two circles, one centered at A with radius AB, second centered at B with radius AB. Mark the intersection point and label it C. So I really only need to find one intersection point, it looks like. So there's my radius AB. So I really only need to, I don't need the full circle here. I'm just going to mark inside the angle. And then I'm going to go over here to this point, and same thing, I'm going to mark inside the angle. So mark this intersection point and label it C. Construct a ray starting at your vertex and going through C. So there we go. Ray VC. I guess I don't need to put the arrow because I wrote ray right there. But ray VC is an angle bisector of the original angle, which was angle WVX in this case, okay? Again, we could check it. Let's take a protractor just for the heck of it. Put that right there. Shrink it down so it's a little bit. So this angle here looks like it's 0, 10, a little above 60, like 64 maybe, a little bit under 65. Keep it right there. Yeah, this is a little bit off, more like 62 or so, 61. So again, it's not going to be perfect. I can kind of see that I'm not going through the middle of that point. I'm a little to the right. So looks like it should have been a little bit more over here, but that's okay. Good enough. I followed all the steps properly. So as long as you guys do that too, it should come out pretty darn close. So thanks for watching this video. I think that's it. Oh, no, wait, we got one more, a couple questions here. What was the first step in each of these constructions? First step, perpendicular line through a point. For that construction, construct a circle centered at the given point. Angle bisector, construct a circle centered at the vertex of the given angle. So construct a circle for both of these. Next question, the first circle creates 2 points that are now the same distance away from the center. Now, where do you see the 2 circles that go through each other's center in each of the constructions? So in each construction, the 2 points created from the first step become centers of circles that go through each other's centers. Okay, so those become your new centers after you construct the first circles. All right, back to our goals. I can define an angle bisector. Good. I can construct an angle bisector using a compass and straight edge. I can construct a perpendicular line through a given point on a given line using a compass and straight edge. All right, if you need more practice of these, I would suggest just like, draw a line, put your arrows on it, put a point on it, and ready, set, go. If you need practice of bisecting an angle, I would suggest just drawing an angle on your paper and ready, set, go. Okay, see if you can do it. All right, and then you can check your work with the protractor, see if it came out right. All right, that's it for today, and thanks for watching, and we'll see you next time.